Hello, respected students.
Alright, so this is 7-6A, moments, centers of mass, and centroids. At the end of this lesson, you will be able to calculate the center of mass for a linear system, a two-dimensional system, and a planar lamina.
Heck yeah, we will.
Right. Okay, so we're going to talk about what a moment is. We're going to start with moment about a point. Okay. A moment about a point is defined as the mass of an object times the distance from the point. So the center of mass occurs at a point where the sum of all the moments on the left and the right are equal. So here's what we've got. For an example, we have a seesaw, right? We have a little girl and a little boy. They're on the seesaw. The girl has a mass of 15 kilograms. The boy has a mass of 20 kilograms. Since they are the same distance from the center, the moment on the right is bigger than the moment on the left, and the seesaw is out of balance, right? If you've ever seesawed with someone who weighs more than you or less than you, right? It wants to go that way. So if we want the seesaw to be in balance, one of two things has to happen. Well, one of three things, really. The boy needs to lose weight, right? Okay. Or the girl could gain weight. We could hand her a big heavy object, right? Or we could have the boy move in a little bit, right? And then if the boy moved in, then the moment on the right would equal the moment on the left, and we'd have a seesaw that is in balance. Right? Or the girl could move out.
Lean.
Okay.
We could just chop off the boy's leg.
Okay, so anyway.
That would be the losing way to approach.
Okay.
We learned the head is 8 pounds.
Alright.
Yeah.
Hey, you know.
What's 8 pounds?
Oh,
in
by the way,
kilograms?
5 kilograms is right around 8 pounds, so you know.
So, to equalize the moments, blah, blah, blah. Alright, good. Alright, I had a GeoGebra link that did not work very well, so I'm not even going to show it right now. But I have another one later on, don't worry, you're not out of GeoGebra yet, because I've got one that'll work. Alright, so, what if you have multiple masses? There is the moment about the origin is the sum of all the moments. So you take all the moments, it's just mass times the x value, add them all together, and that gives you the moment about the origin. For this to work properly, you keep the positive x as positive and the negative x as negative. That way, if your moment about the origin is 0, then you have it's in equilibrium, and you have a balanced axis, right? Okay, so that's the goal. So if you get the total of all of the moments to equal 0, then your system is in equilibrium and the center of mass is at the origin. Alright, and of course, yeah, just make sure negatives stay negative, positives stay positive. So to find the center of mass, if it is not at the origin, we simply take the moment about the origin and divide by the total of all of the masses. So our center of mass, this is just on a linear system. Our center of mass, which we call x bar, whenever you have a bar over a variable in math, it usually means average. So it's kind of an average type of thing here, what we're talking about. So anyway, the center of mass, it's the moment about the origin divided by the sum of, it's the total mass of the system, the sum of all the individual masses. So it's the sum of all the moments divided by the sum of all the masses. Okay, that's your center of mass on a linear system. Everyone good with that? In case you're right, that might be a good thing to write. You know.
Is moment the same thing as moment of inertia?
From what I'm gathering, I think so.
Yes.
Because
I know it relates to it, and I know it relates to momentum, but I don't know if it's if they are equal.
Because moment of inertia is not, it's not mr, it's mr squared. So I'm wondering like how they're different.
Oh yeah.
Don't know.
Well, I think this would be velocity.
We had to sit class together. We sat next to each other.
What's the moment of velocity?
Okay. Alright, here we go. Find the center of mass of the point masses lying on the x-axis if. So take a second and do this. You're given all their individual masses and all their individual x values, distances from the origin. See if you can find what the actual center of mass is.
Is this still a calculator problem?
Everything for this whole unit is calculated. Yes, go ahead.
17.
Do that whole thing in your head. You can reduce the fraction.
Oh, you can't compete with that. Just drop it.
Oh,
Yeah, is it too late? No. I won't be.
I'm not kidding.
I'll stick it out for 2
there's
weeks.
what, like 10 days left, and
Yeah.
if that.
I mean, but this
There's
is
10
gonna
if
be
you
one
include
class,
ten.
so one
Oh,
time I
for
graduate.
seniors.
Seniors,
I suppose for math, like for
Think
third
about
and
all
fourth.
the work I've put in.
I still
and how
feel
it's
like that's just an
negatively
odd
affected my
system
GPA.
where our last day is a half
This
day.
year basically
Like,
killed
I
my
don't-
GPA.
I mean, I kind of do.
I would think finals
Found it
on Wednesday and Thursday are both final exam days, right?
Yeah, that's the theory.
Wednesday is first and second, and
Other way
Thursday
around. Other
is,
way around.
Other way.
Wednesday is third and fourth,
Yeah, that's our last day together.
and Thursday is first and second?
Yes, because
Except for seniors, it's all 4 in one day.
yeah, which doesn't really make much sense. Although most of the seniors I know don't actually have any finals on that day
Yeah.
because they're not actually taking any classes with finals.
We, at my old school, all final exam days were always half days. You never had more than 2 in a day.
Well, that would make sense. Would be to have like Wednesday be third and fourth, Thursday to be first and second. I don't have an issue.
Alright, so for this problem, your moment about the origin is just each mass times its x value, right? So you get a moment of 34. Your total mass is 22, so your center of mass is 34 over 22 or 17/11. Any questions on that? Center of mass on a linear system. Alright, one more center of mass problem. Okay, so I'm just gonna tell you, when in this software program, you can look up little pictures, like clip art kind of pictures, and you can do a search for whatever kind of picture you want. So I did a search for man, and this is what came up, right? So here we go. Yes, I know. Okay,
Very
so,
There's a guy who showed up to the bachelorette when he felt 500. He went home. It was sad.
in order to move a 550-pound rock, a person weighing 200 pounds wants to balance it on a beam that is 5 feet long. I know there's a lot of what the heck's with this problem, right? But anyway, let's just go with it.
I balance rocks on beams all the time.
Okay, good, there we go. So, we're not even gonna think about how he moves the 550-pound rock onto the beam, right?
What if it fell on you?
Perfect.
So anyway, let's just pretend he has a 550-pound rock on one end of a beam. His plan is somehow to lift the beam and put a fulcrum in an exact spot so that when he stands on the other end of the beam, they will be in total balance and he can somehow like move the rock around to where he wants it to go and let it down,
It just
right?
says move it. It doesn't say what direction he. Maybe he just wants to move it up
Maybe
and
he
then
needs
put
to
it back
lift it
down.
up. But, okay. And
He's got something stuck underneath it.
So here's
Maybe
the
it's a person.
situation.
Motivation.
Yeah,
Right?
there's a person underneath.
550 pounds, 200 pounds, total distance 5 feet. You need to figure out where does the fulcrum need to go, how far from the rock does the fulcrum need to go for this to be in balance. Go. Take a minute so you can figure it out.
Just set torques equal to each other.
You're just setting the moments equal to each other.
I got
Right?
it.
Like a moment.
I know why he has to move the rock. So the rock is going to fall, and he's preparing ahead of time. So once the rock falls,
So once it it'll
once
fall on
it
the
falls
spot.
onto his seesaw, he can.
And he'll just stand there and
Yes, it'll
perfect.
Suggest one.
Very good planning.
could be huge.
Oh yeah, it could be Joe Mauer.
Yeah, do the picture.
Yeah.
Like
Just the one
SDF,
that was
so.
on the picture.
Okay. What is it?
Or the G.
Just do 550 times 5.
I got 2 points. I got 2 points. Am I doing something wrong? I
Let
know.
me see your setup. Wait, don't erase.
Oh, it's done.
This is fine for a setup.
That's not what
You
you
just
want.
let extra distance of the man from the fulcrum and the rock from the fulcrum, but that's okay. So then when you multiply it out,
So they have to do
Wait,
it.
550.
I care.
Yeah, that makes it worse.
wait, why do you keep dividing that by? Oh, I see.
It's 0,
See,
so
that's
it's
what five.
Yeah.
When they divide it. Okay, yeah, and this is correct. That's the distance the man is from the fulcrum. You need to subtract from 5 and then find the distance of the rock.
Oh, okay.
Pound is
Yeah, that's what I think too. Did you do 200?
a pound is a measurement. Wait, this price is
Then you're gonna
pound.
get 500
Pound a
times X
measurement of
equals
weight or
1,000.
mass.
It's weight, but we're gonna treat it like mass.
And force.
You
Yes.
can treat because okay.
Oh, yeah, so.
Okay, moving on. Okay, so someone who solved it, tell me your approach. Yes, Trace.
So basically, I had like the human would be like X feet away from the center of mass.
Okay.
So I said 200 times X is equal to 550 times 5 minus X.
Times 5 minus x. Good. So when you solve for x, you got the distance of the man from the fulcrum, and then you have to subtract from 5 to get the
Yeah.
distance of the rock from the fulcrum, right? So I actually did it the exact same way, except I had, come on.
That's just cheating.
Yeah, it's just evil. I
Wait,
can't
can you
reverse
spin
it
it?
anyway.
Can you, no,
No.
can you just like, oh, you can't?
No, I can't, I probably could rotate it.
Yeah, rotate it
That's
upside down.
Okay,
Actually,
anyway, I put the x here and the 5 minus x here, and that way it was just a quick, when you solve for x, you get the distance you want. Right. Okay, any questions on that one? Kind of a little logic problem? Alright. Good,
please tell me it doesn't get harder.
moving on. Alright, so now that was one dimensional. Now we're gonna do 2-dimensional. Now, with a 2-dimensional system, let me pull up this awesome GeoGebra demonstration here.
Not a fan.
Okay? Alright. So, what we have is we have 3 circles, and the size of the circle represents the mass of the circle. Alright, it's called a point mass. So let's just pretend the bigger the circle, the heavier the circle, right? So this dot right here, gentlemen, this dot right here, that's our center of mass. The center of mass gets pulled towards the heavier object because we want the moments to all be the same. And so remember, it's the mass times distance, right? Mass times distance, mass times distance. So when you have a smaller mass, you need a bigger distance. When you have a larger mass, you need a smaller distance, right? So if I were to make this one smaller, my center of mass would go further away, right? And if I make this one bigger, it gets pulled that way, right? So if I make this one bigger, it gets pulled that way. If I make them all the same, okay, I have it. Shoot. There we go. If I make them all the same, then the center of mass is truly in the center and it's just equidistant from all 3. Okay, so this is 2-dimensional system. This is what we're about to do, is find centers of masses on a 2-dimensional. Alright, so I want you guys to try this with no instruction at all.
No.
Yes, so find the center of mass as an ordered pair for the given system where you're given a mass and an ordered pair for each point mass.
Could you just find the center of the y? Is that good sound right?
Just the, yeah, it is with price. You slide on.
I feel like upset.
I don't know what I'm sly about, but
I feel like they.
Well,
You know full
I think
well
you
when
know
you're
full well when
sliding
you're
your
excited on
mouse.
this, right?
not okay.
It's been scored.
Oh boy.
It's 5-4.
Nice.
So
They
they-
kind of really let it go in the fourth inning there, didn't
Yeah, they went 3-0. And
Yeah,
then now it's 5-0,
now it's
5-3,
5-4
but-
because
I'm sure the game gets
What is it?
affected by the time the score.
Oh.
I'll just
We're-
keep you
All
honest.
right, let's
We're a
get
photograph
focused
are now like
on our-
10-5.
Just
Right,
look
let's
at,
focus
just
on
look
our
at
math.
the man.
But baseball does have to do with math.
Yeah, but not this problem.
Wow. Yeah, we've
What
done
about
baseball
that?
problems like all last
I'm
chapter.
just.
What if I talk about Danny Santana getting a home run or something? I'm just like, oh, he hit it at an angle of at least
0.5 rate.
Hey, we did that last
Yeah.
unit.
Yeah, exactly. That's what I'm saying.
Yeah.
I
You know,
it's calculus related.
Yeah.
I think we gotta go to a baseball game as like a field trip for Cal 3 next year.
No, dude,
We could
watch
do-
it golf.
Nah, she's right. Not with the way the
Math,
Twins are
and we
playing.
could have like a
Go to
golf
a
ball, a
Saints-
baseball, and basketball.
You know what's even better than that? How about, I mean, you know math has a lot to do with computer programming, right? Why don't we watch
No, it's
a
not.
live computer programming and do League of Legends streams?
Top 5 NFL.
What? Why?
Cause we're gonna be amazing.
No.
Now there's the Steelers.
You know why we
How about
won't?
the Colts?
Because we live in Minnesota.
Andrew Luck.
Mr. Thomas is saying.
What, like, hey Sam, great idea,
Vikings.
right?
Luck is in the
Yeah.
I'm feeling it.
What?
We did well last year,
Why I
but
just
all
said
let us
okay.
down with
I don't
missing the
Oh.
Alright,
field goal.
quiet please.
The Colts are
So,
gonna be
someone give me someone that hasn't talked yet, someone give me a strategy for how you approached the problem. Yes, JJ.
So, if you do the same process that we did just for the X, and do it for the X and the Y, and then take both answers.
There you go. So, you're just finding the moment for you do the center mass for the X, you do the center mass for the Y, and then put them together. So, in this case, your center mass is the origin. Look at that.
So,
I feel
why?
like, could you just guess?
I got
Be
0
like,
on
ah,
it, that's
the
all
origin.
good.
Is
You got
every
0
single
what?
one-
Yeah, and then I was like, that can't be right.
Yep, it was right. It was right.
Be confident.
So no one received.
Okay, yeah, so when you need to do 2 dimensions, you just do the X's and the Y's separately.
But there's gonna be.
But wait, there is more.
Rats. Now we're gonna have to derive it.
Alright, are we ready?
No.
Okay. What the heck is a planar lamina?
I don't know. That's
Yes.
Okay.
I wanna know what the type
A
of-
planar lamina is a thin, flat solid of constant density, such as a sheet of paper or a sheet of metal, right? Okay, so a thin, flat solid of constant density. If the lamina is symmetric about a point, such as a circle or a rectangle, then the center of mass would be at the center of the object. Yes?
This by flat doesn't mean that it has no.
No, it has
Depth.
thickness.
It does?
Yeah,
Okay.
yeah, it's thick. So it has thickness, but it's the same.
Uniform.
It's uniform. Let's say that, of uniform thickness or density, I guess both, really. So anyway, a planar lamina. So for a triangle, the center of mass is at the centroid, which of course is the point of intersection of the what's.
Bisected perpendicular.
Close.
Just regular bisectors.
What do you mean by
I mean,
bisector?
like,
Bisectors?
you chop the
You either have
sides down,
angle bisectors, you have perpendicular bisectors.
Perpendicular.
the side bisectors.
That's
So-
what I
Okay,
said.
but you mean by the medians?
Wait,
Oh, that's what
I
they're
said.
called.
That's not what you said.
Where you get a line and then you like take the middle and then you grab the normal line to that, but you don't.
That's a perpendicular bisector. Median connects a vertex to the center on the
I
opposite
do
side.
that.
And that's what a centroid is. It's the point of intersection of the 3 medians of it.
I knew that.
So, okay.
Pretty
So,
standard.
I
anyway,
don't believe you.
all right.
You couldn't crush my hopes and dreams.
Think of it as though the object is rigid and you are trying to, no matter what the shape, it could be any funky shape, you are taking it and you're trying to balance it on one point, right? That point would be the center of mass. So it has to be rigid though. You can't really do it with a sheet of paper, right? 'Cause,
I got it.
yeah, good luck with that.
Here.
Alright, the mass of a planar lamina is equal to its density times its area. Area times density. If the lamina is a region bounded by two curves, we can, and we will, use an integral to determine the area. Alright, so in order to find the center of mass of a region bounded by two curves, you need a system of 4 formulas.
Oh my gosh.
Here we go.
Oh, good God.
I'm so.
Okay.
Are these all, okay, if you have to memorize.
I don't have a sheet of
Now.
paper for this.
Now,
We have to memorize all of this.
yes, you do. Okay, I'm gonna quiet
You
down.
don't necessarily.
Okay, get the complaints out, and then we're gonna move on.
I'm so mad.
Okay.
I'm gonna do
All right.
I am so frustrated.
I'm gonna sue
All right.
you
Okay.
because you're annoying.
All right.
Oh,
Quiet. Okay, that's enough complaining. Now we're gonna focus.
What the heck?
So, the Greek letter rho here that's in front of all of these, right, that rho represents the density. One of the things to note is that the density is irrelevant when finding the actual center of mass. This is the moment about the y-axis. By the way, this can be confusing. Listen up. The moment about the y-axis is a horizontal moment. If you think of the y-axis, and it's the balance about the y-axis, so it's that horizontal moment. The moment about the x-axis is a vertical moment. And then, so like people get confused when you find your center of mass, it's m sub y, that's your x value, and m sub x over m, that's your y value. Alright, so moment about the y-axis, moment about the x-axis, the mass of the region, right? So it's just same as before, moment divided by mass, right? Gives you your center of mass. So mass of the region, density times area. Everyone's got that. Area is the same old area it's always been, top minus bottom. Here's the trick, and I have not yet become comfortable with how these are derived, so I'm going to give you what I know, and then you can take with it what you will, all right? Because you're the one that always wants to know how it's derived, which is a good thing, right? Okay, so here's all that I gathered from what I've read so far, and I haven't spent enough time on it to really wrap my head around it yet. So say we have two curves, and say we're finding the center of mass of this space, right, between these two curves. So this is F, this is G, right? Now, we know, and we'll just, whatever, A and B. All right, so we know that to find the area, we just do top minus bottom, right? And the mass makes sense, it's density times area. Okay, so I get mass, right? Here's where these two formulas come from. You take a rectangle. So take some little rectangle in here. So if you break it into teeny tiny rectangles, I'm going to use big one just for demonstration purposes. So you break it into teeny tiny rectangles. If we want the center of mass of that rectangle, the center of mass would be at some distance x, and then the height, let's draw this sideways, the height to get this y value would be the average of these two. It would be f plus g over 2. So this y value, right, you take, it's the average of these y's, right? F plus g over 2, that's the y value. The x value from the x-axis is just x. So we have, for our moment about the y-axis, it's the area times x. For the moment about the x-axis, it's the area times f plus g over 2, which is the y, for the center of an individual little mini rectangle in the region. Yes?
When you say moment about the x-axis, I'm not envisioning what you mean. Do you mean?
Okay, a moment isn't a thing, and it isn't a distance. It's a measurement. It's weight times distance,
Okay.
right? So remember when we just think simple like the seesaw,
Right.
right? So you have a moment on one side of the center and a moment on the other side of the
Okay.
center. And for equilibrium, you want them to be the same,
Right.
right? So in a linear system, it's pretty straightforward. Take this mass times its distance, this mass times its distance. You want them to be the same for about, and they would be the same about the center of mass.
Okay.
So what you're doing when you have this funky shaped system is you're basically finding the moment about, and it's kind of like an average, but you're the moment vertically and the moment horizontally, and then dividing it by the mass to get the actual center.
Okay.
I don't know if that helped at all, but anyway, that's the best I can do right now. So did that help a little? I don't know if that made any sense or not. Okay. So anyway, so
We can
here's
pretend.
your formulas, right? So you kind of start mass, just area. Y-axis, area times x. X-axis, area times average of the y's. All right? So there's your three formulas, and then you just divide to get your center. All right, so there's your four formulas, and remember, the density is completely irrelevant, because if it's a uniform density all the way through, then the actual density isn't going to affect the center. The center is the center, no matter what the density is, right? So the density will always cancel out. So there are some problems where you're not even given the density, and it doesn't matter. So if you're just asked what's the center of mass, you don't even have to use the density. You just leave it out. Do the integrals without the density, and you'll be fine. All right. Here we go.
Oh, out of curiosity, but will we ever learn how to do problems that do involve density?
Your first problem in your homework has density in it, but you multiply it in, you get your moments, but then you're going to divide it out when you find your center.
So it's unnecessary.
So it affects the moments, but it doesn't. But the center is the center regardless.
Like if they ask for the moments.
Yes, of course. All right, so we're going to find the center of mass for the planar lamina bounded by y equals root x and y equals x. Yeah. Okay, so y equals root x. Okay. So y equals root x looks like that. Y equals x looks like that. We're dealing with this lovely little slice right there. Okay, points of intersection. Remember, these are all calculator questions. You can find the point of intersection on your calculator, but I'm hoping that you would know this is 0, 0, and this is 1, 1. Right. Okay, so I want you to take a minute. All you have to do is set up answer, find the moment about the y-axis, find the moment about the x-axis, find the mass, and then find the center of mass.
What does P stand for again?
Okay, it's not a P, it's a rho, but either way, it stands for density.
Doesn't matter.
It's a Greek letter.
Can you go back to the previous slide briefly, because I may have
just
forgotten.
one.
All right, going back to the previous slide for one moment in case you need the formulas.
What was the formula for density?
Are you just doing density for as one?
Yeah, if you're not given density, just let density be 1.
Yeah.
Oh, okay. Can you go back to the other one?
In just a moment.
Okay.
Just a moment.
Ah.
I'm so
mad.
Well, Miss Price, if you're so funny.
Thanks.
Was that sarcasm, Brian?
Yeah, Brian, what was that?
No, I know that was sincere.
That sounded
Yeah,
quite
yeah.
genuine.
Yes.
Shoot, I forgot the formula for like math.
It's
Home straight maybe.
The twins are winning.
I know. I get
I
nervous.
have it on my phone.
I do too, but apparently they don't actually like make any vibration or noise or
Oh. Mine makes
Does it matter what F and G equal or not?
It's straight up just.
F is always on top. F is always the function that's on top, and G is always the function on the bottom. The area is always top minus bottom.
No, that's not.
Can I have your
Yeah.
Thank you, sir. All over.
Wait, when you're thinking about moments around an axis, could you treat that axis as like a fulcrum? Like if you want to visualize it, I guess.
Sure.
Yeah, the problem is that
And each
like
point is like a line.
And then like you
Yeah.
have a
Yeah.
linear fulcrum and a
Yeah.
linear fulcrum, and then you're trying to find where they
Yeah.
coincide. Yeah, that's
Yeah.
I can kind of see that a little
you
bit.
just don't know where the fulcrum is.
Well, I mean, that's to like visualize the idea that my over m is the x coordinate,
Yeah, I'm gonna
Right.
say.
and mx over n is the y
Y,
coordinate. You could think of it as that as the fulcrum.
You use that line a lot? You know, I don't trust Lyle. I don't. I do. I'm judging your
F minus yeah. I have .4, I got .4, oh crap.
I got the two right. I think I
Yeah.
have mine in fractions, but it could be. I'm not positive.
Oh, I know.
Alright. For the first, I'll go and show you the moment about the y-axis. Now, I kept the rows in. I kept the densities in just for demonstration purposes to show you that later on they will cancel. So you should have just gotten 1/15. Right? I got 1/15 row, but
That's what we have.
no?
I'm not.
This is for M sub y?
Yeah.
Oh, okay.
What?
Oh, I did it in decimal, but let me.
Decimals are okay. I think it's point 16666.
Oh, yeah.
Point oh, wait, wait, no.
Oh, point oh 6666. Okay, thank you.
Yeah, the mass is. How do I change this back to the?
Yes.
Ah, okay. I knew there were a bunch of sixes and no ones.
Hey Dylan, you see some,
Yeah. They're up.
Come on.
Alright, anyone need another minute? Works.
Oh, we gotta find them.
It's also the mass
You're an
mass equals
It's F minus.
C is the standard.
You have it written right.
Like a standard heat, specific heat. Mass equals specific heat temperature.
Yes. How about you, Jack?
That's easy. I mean, I think you learn it.
Look at all on our phones.
Snyder today. And yesterday.
Alright.
Oh my god. AP is like 90% titration.
X, going about the x-axis, should have got 1/12. Your mass should have been 1/6. And I did all of these by hand, but you do not have to do them by hand. That's why I circled. Like, all you have to show me is setup and answer, right? Setup and answer. Setup and answer. Alright?
Is the test gonna be entirely calculated?
Yes. Test is all calculated. And then your final center of mass. So here's the thing. So when you get your moment about the y-axis, which is p over 15. Oh, I did it now. Rho over 15. And then divide it by the mass, rho over 6. The rows cancel, right? So the rows will always cancel. So you don't need the density in order to find the
We
center.
don't even need to, do we have to write them?
No, you never even have to write it.
So you won't take out
Unless
points
we,
from our setup?
unless there's a problem that specifically says, what is the moment about the y-axis
You
then,
choose this one now.
right? Because it technically is 1/15 times the density.
But if you were grading this problem for the final answer and looking
Then
at
that'd be fine, yeah, and without any, I wouldn't put it in. As a matter of fact, part of your homework is literally, hey, ignore the row and just put 1 for it and see what happens, right? Trying to get it easy. So anyway, but 2/5, 1/2,
Keep going. Well,
alright.
I was like, people like, people
So we'll,
I like the
Yeah, wait.
Okay, guys, quiet please. M sub y is not the y center of mass. It's the moment about the y-axis, so it's actually a horizontal moment. And M sub x, so don't be deceived by the labeling, right? M sub y gives you the x value of your center, M sub x gives you the y value of your center, all right? Okay, because it is what it is. All right, so what have we learned? Now don't worry, if you're thinking we haven't done enough practice, I've got lots of good practice for you, so don't worry, okay?
Not worried.
So, really quickly, can you find the center of mass for a set of point masses on a linear system?
Oh, yeah.
What about on a two-dimensional system?
Yeah.
Okay, how about for a planar lamina? Yes, eventually with some practice.
Oh yeah, before you got the camera, I'd just like to say that the Beatles are the most overrated band of all time.